Across the globe, our planet is whispering, no, shouting a message. It's a message etched in the fury of hurricanes, the tremors of earthquakes, and the fiery breath of volcanoes. It's a message of change, of instability, of a world struggling to find its balance in the face of a rapidly changing climate. In 2018, the Hawaiian Islands, known for their volcanic beauty, bore witness to the power of this change. A deluge of biblical proportions, the heaviest rainfall ever recorded in the United States, pounded the islands. A staggering 1,262 millimeters of rain, imagine a meter-high wall of water, fell in just 24 hours, smashing the previous record set in Texas back in 1980. But the heavens weren't done yet. As if awakened by the deluge, the Kilauea volcano, a fiery giant long accustomed to slumber, roared to life. Lava, molten rock, glowing with the Earth's internal heat, surged across the land, engulfing homes and reshaping the landscape. Scientists, witnessing the sheer scale of the eruption, could only describe it as an event of unprecedented proportions, a once-in-2 centuries outburst of the Earth's awesome power. These events, though separated by thousands of miles, are not mere coincidences. They are stark reminders of a profound and unsettling truth. Our planet's climate and its geological stability are inextricably linked. The Earth's crust, the seemingly solid ground beneath our feet, is in fact a dynamic and ever-shifting mosaic of tectonic plates. These plates, colossal slabs of rock that make up the Earth's outer shell, are in constant, albeit usually imperceptible, motion. They grind against each other, pull apart and collide, their interactions shaping our planet's magnificent landscapes. Mountain ranges, ocean basins, and everything in between. Climate change, however, is adding a dangerous new dimension to this ancient dance of the continents. By altering the delicate balance of weight and pressure on the Earth's crust, it's increasing the likelihood of geological upheaval. Imagine a seesaw, add weight to one side, and the other side rises. This simple analogy helps us understand the impact of climate change on the Earth's crust. Consider Madagascar, an island nation renowned for its unique biodiversity. Sadly, it's also a region grappling with some of the highest rates of soil erosion on the planet. Each year, vast quantities of fertile soil, the lifeblood of agriculture, are washed away by torrential rains, leaving behind a scarred and depleted landscape. This relentless erosion, exacerbated by deforestation and increasingly erratic weather patterns linked to climate change, is literally lightening the load on the Earth's crust in Madagascar. And as the weight lessens, the ground beneath responds, sometimes with unsettling consequences. Meanwhile, on the other side of the world, a different but equally dramatic scenario is unfolding. As global temperatures rise, glaciers and ice caps, those frozen reservoirs of fresh water, are melting at an alarming rate. This meltwater, carrying with it the legacy of millennia-old ice, flows into the oceans, inexorably raising sea levels. The rising seas, however, are not simply a case of water expanding to fill a larger container. They represent a colossal weight pressing down on the Earth's crust, particularly the oceanic plates. This added weight, scientists believe, can have profound implications for geological stability. Imagine a finger pressing down on a soft rubber ball. The ball deforms under the pressure, bulging slightly at the sides. Similarly, the immense weight of the rising seas can cause the Earth's crust to flex and buckle, potentially triggering earthquakes and volcanic eruptions in regions already prone to such events. Furthermore, this added pressure can also influence the movement of magma, that molten rock that lies beneath the Earth's surface. Just as squeezing a tube of toothpaste forces the paste out, the weight of the oceans can, in some instances, squeeze magma upwards, potentially contributing to volcanic eruptions. Section 4. A delicate balance: ice loss, drought, and the shifting ground beneath our feet. But the interplay between climate change and geological activity isn't limited to rising sea levels. On land, the increasing frequency and intensity of droughts, driven by shifting weather patterns, are also leaving their mark on the Earth's crust. When a region experiences a prolonged drought, The water stored in the soil, water that acts as a natural lubricant for the Earth's crust, gradually evaporates. As the ground dries out, it contracts, shrinking like a sponge left out in the sun. This contraction can alter the balance of stresses within the Earth's crust, potentially triggering earthquakes. Paradoxically, the opposite phenomenon, extreme rainfall and flooding, can also influence seismic activity. While heavy rainfall might seem to have the opposite effect of drought, saturating the ground with water, it can actually reduce the weight on fault lines. Imagine a heavy object resting on a slippery surface. Reduce the friction, and the object is more likely to move. In a similar vein, heavy rainfall can lubricate fault lines, making it easier for them to slip and trigger earthquakes. Section 5. Echoes of the past, warnings for the future. Lessons from ancient climate change. The link between climate change and geological upheaval is not a new discovery. Scientists studying Earth's history have uncovered compelling evidence that past periods of climate change have coincided with significant geological events. For instance, the last ice age, which ended around 11,000 years ago, saw dramatic shifts in Earth's climate, with massive ice sheets covering vast swathes of the northern hemisphere. As the planet warmed and these ice sheets melted, the Earth's crust, relieved of the immense weight of the ice, began to rebound, a process that continues to this day. This rebound, known as isostatic adjustment, caused significant geological upheaval, triggering earthquakes, volcanic eruptions, and even tsunamis. It serves as a stark reminder of the profound and lasting impact that climate change can have on our planet's geological stability. Today, as we pump greenhouse gases into the atmosphere at an unprecedented rate, we are essentially conducting a planet-wide experiment, one with potentially catastrophic consequences. The Earth's climate system is incredibly complex, and scientists are only just beginning to unravel the intricate ways in which climate change can trigger geological events. Section 6. The urgent call for action, protecting our planet, protecting ourselves. The evidence is clear. Climate change is not just an environmental issue, it's a threat to our very survival. It's a threat that knows no borders, affecting every corner of our planet, from the highest mountains to the deepest oceans. But there is still hope. We have the knowledge, the technology, and the resources to avert the worst impacts of climate change and build a more sustainable future for all. But we must act now with urgency and determination. We must transition away from fossil fuels and embrace clean, renewable energy sources like solar, wind, and geothermal. We must protect our forests, our oceans, and our biodiversity, for they are the very lungs of our planet. And we must invest in research and innovation to develop new solutions to this global challenge. The Earth has provided us with a home, a place of breathtaking beauty and wonder. Now, it is our turn to protect it. The future of our planet and the future of humanity depends on the choices we make today. Let us choose wisely, let us choose action, let us choose hope.